Where's my book? Tony, did you take my book yesterday, or did I take it back?
No.
Of course not. Then where is it gone? I don't have it anymore. Are you sure you didn't take it? Absolutely, huh? That's yours, okay, where's mine then?
You have to write some name in the top.
Do.
Then we take a picture and we'll take it back.
I'm going to borrow your book today. Okay, page 22, please. Too easy, don't read it. Page 22. Okay, got that? Yes. Ready, guys? Guys. Okay, so for this lesson, we're going to have a look at another type of plot. So far this semester, we've done cumulative frequency, line graph, histogram, and now scatter plot. So already we have 4 different types of plots for semester 2. Whereas in semester 1, I suppose there was 4 as well, but that was for the whole semester. There's only really one last plot to do, so most of the graphs are going to be finished today. And the scatter plot is actually a pretty easy graph as well. So let's have a look at it. Scatter plot. So last time, previously on maths class, we've seen that you use a line graph when you have what situation? So what's special about a line graph? Why would you use a line graph, or when would you use a line graph? Continuous, yeah, but something special about the line graph. It's something about the x-axis.
Time.
Oh yeah,
Time.
Time. So for a line graph, the x-axis is always time. Cumulative frequency and histogram, you can use it for any continuous data. And what we're going to look at today, scatter plot, again, is continuous, like height and weight and stuff like this. But what's special about scatter plot is that the data, it's not only x data, that the data is in pairs. So for example, e.g., you might have like an x with a y. So your data could be something like this: 0, 1, comma, 1, 2, comma, 3, 9, comma. That your data, they're pairs. So this is different to last week, because last week our data was really just a list of numbers like 1, 3, 6. That was last week. So today our data now, it goes in pairs. So this is the key thing about a scatter plot, is that your data must be in pairs, like x and y. Fair enough. Now, in business, what might be an example of some data like this, where each element is a pair, each member is a pair? Any examples you can maybe imagine? It doesn't have to be business, anything. What can you think of?
What do you mean by idea?
That for every element is not just one number, but two numbers that go together. I'll give you an example.
Is it given?
Yeah, something like this.
Quantity
So,
and price?
yeah. Quantity and price, right? In economics, when you have a quantity, then you have a price that goes with this quantity. Yes? What about something else? Something else.
Cost and quantity.
Yeah, maybe something else away from quantity. But yeah, something like this. Business or economics or anything.
Profit and cost.
Yes, but something more interesting.
Business size and profitability.
Business size and profitability. Yes, something more interesting. What about something like with inflation?
Interest rate and inflation.
Interest rate and inflation. You can pair them together. Yeah? What else with inflation? There's something else that usually goes and pairs with
Income.
inflation.
Income.
Yeah, no, something else. Something else.
Percentage.
Hmm?
The percentage.
Yeah, percentage of
Economic
inflation
growth.
and maybe economic growth. Or inflation and unemployment. That these could be paired together. So a scatter plot is a way to draw the relationship between the two. So for example, if you think about economics, and if you have inflation as the x, and unemployment as the y, what's the relationship? What do you think? So if the inflation is big, what does that mean for the unemployment? What do you think?
Increase.
Right, you tell me, you're economics students. Have you done this one with Donald? Okay, so right. Let's try a different one. Have you done interest on inflation?
We haven't started macro.
Ah! Well, then forget about it. Okay, let's do something else then. So we have height and weight. So if you have a height and a weight, what's the relationship? So if the height is big, then the weight should be big. Yeah? Let's have a look at what you need for a scatter plot. So for a scatter plot, they look like this. This is where you put the x, and of course it has a unit. So for example, if it's height, what's the unit? Probably cm. And, oh nice. And here is the y, and that has a unit. You'll be fine. Don't worry, I'll protect you. Yeah, you're so screwed now. Alright. So scatter plot as x and y like this. But usually with a scatter plot, when you put the points on it, they don't make a nice shape. They kind of fall a little bit random. So you would never do this. So don't even draw this red part. This, so bad. No. For a scatter plot, you try to draw something which is, nearly going through the points. You never do this. This is very bad. So you can maybe draw a line, okay? Or you could maybe go, oh, this is kind of a curve, if you want. But you never connect like a line graph. Okay, never do this. It's not a line graph. Yeah?
In physics, uranium and radiation.
Yeah, there's many things, physics, science, biology. So you could have like amount of a material and its radiation. You know, you have graphs that can go down as well. There's many different types. So let's have a look at our first example. So you don't need to write that. We're going to do an example together. So we'll open up the... Now, funny enough, actually, I was doing something in physics with those mostly terrible physics students, except for two, of course. Two boys. Yeah. These are the only two good ones in physics. The rest, no good. No, not Patrick. What's his name? Maybe Andy, maybe, and Hareen, maybe. I think. Yeah. The rest, no good. Yeah. Okay. Does everybody? Let's see. What information would everybody have? Would everybody know their height?
Yeah.
Roughly. But everybody know their weight. So that's all right. We'll do something else then. Height and what else? You don't want to tell me your weight.
You get it.
You can make it.
Yeah, just get it.
Guess.
Yeah.
Whatever.
If you are 100.
No, that's worse for me because if I guess too big, then this is bad. I'll just make up some height. So we'll have height in centimeters, and then we'll weight or mass in kilograms. So I don't even know what be a normal example. Okay, thank you. Are you 170? What are you?
174.
Okay, and what's your weight then? Don't know. Does anyone know? And they can give it to me. I just need one example. Your height? Does anyone know their height and their weight together? Yeah?
So it's like around 70 to 75.
Okay, so you are 72. And what's your height?
Not me. I just.
Oh, okay, fine. All right. So you're saying he's 72 then. That's fine. Okay. So let's make 72. No, I don't even think he's 60. Yeah. 60. Low 60.
He's not normal.
We'll give him 62, I think. Yeah. 72. No. Right, so we'll say 174 and then we can say 180, so that should be a bit heavier, shouldn't it? What we say, like 70? Yeah. 170, 60. Yeah. 165, 50. 171, we'll make this person a bit heavy, 64. 161, well, let's go with something crazy like 49. Yeah, I know. 150, 40. Yeah, okay, 150, 100. And then we'll go with 190. 90. No. Yeah.
This man I want to
Oh my God.
Yeah. This one's a problem. And 2 meters. So. Yeah. We'll say 100 or something like that. Yeah. So this can be like a rugby player or something, a football player. Right. Okay. So I'll just give you a minute to write these down. Now, which one you put on the X and which one you put on the Y, that depends on the question. So, if you have something like height and mass, for example, height and weight, which do you think is probably the one more useful on the X and more useful on the Y? Height is usually what goes on the x, because if you know the height, you want to know the weight, normally. Okay, so just write these 10 points down. Yeah. Yeah. Good, okay. Now, I know we were joking, but actually, I did want to have the 100 kilogram person there, because there actually is a name for the point which is very different to everyone else. Oh, you know this word, very good, yeah. It's called an outlier. Yeah. Where'd you learn such a word like that? You just knew it? Or you picked it up somewhere, yeah?
I've done it.
Oh, you've seen this, but yeah, outlier before. Okay. Have you got this? Yeah. Okay. So let's make the scatter plot chart. Now this will be an important part of your assignment in semester 2. Okay, so make sure you make everything clear. X is height in centimeters and Y is mass in kilograms. And the title is Mass Against Height Scatter Plot. There he is. Now, if you were to draw a curve or a line or a shape, what shape do you think you would draw? Would it be a straight line? Would it be a curve? What do you think? Yeah, I think what we will do, and what you do in the exam is it's always a straight line. But you realise maybe in real life it's not a straight line. Maybe it's kind of a curve shape to it. But for scatter plots, we usually draw a straight line. Now, can you draw a straight line through all of these points?
Possible.
Not possible, because they don't make a straight line. So what you do, you draw a line and you try to make the line go through the middle of the points. So some of the points will be above the line and some of the points will be below the line, but you can't go through all the points. Okay? Now, there is one point that you always go through, which is not drawn here, which I'll show you in a minute. Actually, I'll do it here. I'll show you right here. Before you draw this, let me just shrink this out of the way. So when you draw the scatter plot, before you draw it, you must work out the average of each, the height and the weight. And your scatter plot, 171 and 69 about. Okay, so if you go down here, 171 and 69, it's around about here. It's not drawn on the graph, but you always make sure your line goes through the average. That is very important. So in the exam, when you make this graph, I would check that you drew your line going through the average. Now you need to calculate the average. Yeah. So what was, I think I said the average was 171, and then the mass was about 69. So you can't really see it because I didn't draw it, but your line must go through the average, always, every time. Okay. So I'd like you to draw this now, and I want you to make a note that it must pass through the average. Yeah. Oh, just nothing special, just like what you did last time. So just take the x's and average them, mean average, and the y and mean average them. So here's the average here. Let me shrink this down so we can have them side by side. One sec. Okay. So you see these two numbers here is the average of height and weight. So I want you to make a note about the average, okay? That's really important for the graph. I want to see beautiful graphs. Because in the exam, if they ask you to draw something on graph paper, you get marks for your accuracy, how accurate you are. Through it, yeah? How pretty is it? There's barely any sparkles on it. Well, I can see one problem. Don't you see? What? Tell me. No, nothing that you need to erase. Something you need to write in. What is it? Yeah, there we go. That would have cost you a mark. Yeah, I'm strict like that. Good area. Can I make this graph bigger? Because I want to do something with the graph in a minute. So if I just, where's full screen? There was full screen somewhere, wasn't there? Full screen. Great, okay. Now, you really should in the exam start at 0, but but you can't really do that here, because if you did, there would be a very big gap. I mean, it will be big empty space, and then you got your numbers. So in the exam, if you skip at the start, like here, you must do this. Yeah, if you skip, so for example, if you start at 140, not 0, you must write this little symbol here. And that means you're skipping some numbers at the start. It goes up, down, tick. Yeah. Okay, now, as I was saying to Remal actually earlier, our sick man over here, who's about to die, he has a name on this graph, because if you look at that point is very different to the other points, isn't it? I mean, it's very far away from the line. So he is not normal. No way close to normal. So this has a special name. You call this point an outlier. It lies on the outside. Outlier. Just like as it sounds. O-U-T. L. No. No. Not a liar this way. Lies outside. So L-I-E-R. It's like on the like lies outside. O-U-T. L-I-E-R. outlier. Okay. So usually for your scatter plot, there should be at most one outlier. Just like there will be one student who will do the graph wrong, there's always one point which is not like the other point. Yeah. Okay, now, other questions they could ask you from your graph is they could ask you to estimate the slope of the line, the M. So, what you do for that, if you have a line and you want to know the slope, you draw a triangle like this. It doesn't matter, but the bigger the triangle, the better. This is height is delta y, and this height you call delta x, and the slope m will be the delta y divided by the delta x. But don't forget the minus if it's going down. The line is going down, okay? So there's a plus minus as well. This one, the slope is positive, and if it was going down, then make sure you put in a minus for going down. Yeah?
How do you make another point?
Hmm?
Use the mean average point and use another one.
No. For this, you measure it on your graph paper. That's what I'm saying.
Use
A ruler to measure the two. Yeah. I'll show you this one with an example.
Is it accurate?
Oh no. Well, it can be pretty accurate. What do you mean by accurate? How much error? 1%? 5%? I'd say it should be 5% error. That's okay. Alright, have you got that? Yep. So let's go back to our graph. So what I want you to do on your graph is I want you to draw the triangle and then tell me the delta y and the delta x. Yeah. So now I want to see triangles on your scatter plot. Yeah, so when you draw the line, make a triangle. What's wrong? Oh, something's wrong. Apart from sitting beside her, what else is wrong? Now you see, because I didn't say who when I said you, both of you were thinking, maybe I was talking about you. Yeah? So I want to see triangles. No, we'll get to that in a moment, don't worry about that. First draw a triangle. Now the goal is to make the triangle as big as possible, so if you want to go to the ends of the line. Have you drawn a triangle now? No? Yeah, don't worry. Like, you just pick the end point. And you want to go down a little bit, you know? And then here you want to go across. Yeah, so you can make a triangle this way. Now, it doesn't matter. You can make it smaller, but it's more accurate if you can fill in the whole line. Yeah. Good. Okay. And now that you have a triangle drawn? Yeah. Okay, yeah, that's alright. Alright. Let's now.
But the considering,
Yeah.
the line is like doesn't have start and end, so
You pick the start and the end, that's fine. Yeah.
Is the line to run through zero?
No. In fact, it usually doesn't. Yeah. Okay.
for the equation.
Yes. That's what we're getting to. Okay, have you all done that? Yes? So, calculating the slope of the line. So let me draw that in if I open up Paint. Alright. Have I got full screen mode here? Yeah, okay. Right, so what you should have, let me draw it in. Line from here, make it bigger. from here to, well, what I can do is I can go down more than I need, and then go across more than I need. There we go. Yeah, and then let's put in the colors now. So this is the delta y, and then this is the delta x. So I need to read these numbers. So the delta x goes from, what we say, 151 to 200 about. Oh, it's actually 150 to 200. So how big is the delta x? 50. 50. You can't see 50. That's okay. I don't need to see it. I'll just write it in. So this one here is 50 centimeters. Alright. Now, let's get the height. So it goes from here. Yeah. It goes from here. What's that now? About 85? 90? Okay. And then the height goes to, starts from 55. So 90 to 55, was it? So what's that? 35? 35? So the height here is 30, I'm sorry this is so ugly, 35 kilograms. So if I go to a nice picture, this one was 50 centimeters, and this one here was 35 kilograms. So what's the slope here? 35 over 50, which is 35 divided by 50, which is 0.7, isn't it? Yeah. 0.7. What's the unit? It's not kilograms, it's not meters. What's the unit? Yeah, kilograms per centimeter is the unit. Yeah. So another important thing about a scatter plot is the slope. And sometimes they might ask you to explain what does this slope represent. For height and weight, what is the meaning of saying this on the graph? In your view?
0.7 kilogram
Yeah.
per centimeter.
Correct, that is right. And what does that mean?
Per 1.
Yeah, but what does that mean? Now we're getting closer, yes?
The quantity that you have in kilograms.
You're so close, but not quite there. Do you want to try? I think you have it, what is it? That's the one I'm looking for, which is probably what you meant. Yeah. So the meaning here is that for every 1 centimeter of height the person gains, their weight should increase by 0.7 of a kilogram. This is the meaning of the slope. So for example, if you were talking something about, this should remind you a lot of elasticity. Isn't something, price elasticity of demand or something like this? That for every 1% increase in the price, the demand increases or decreases or whatever. Yeah. This is in semester 1. So what is, but similar. Like for example, you don't, well okay, you have, well let's take something like supply demand. So what's on the X? What's on the X? Demand. And what's on the Y? Price. So what is the unit for the slope? If you think about it.
Amount of money per...
Yeah, so it'd be euro price per quantity. So imagine that this was money. I had 0.7 euros per quantity. What does that mean? Oh, and it probably will be minus 0.7, the graph goes down, doesn't it? Yes, if I have minus 0.7, what would that mean? Yeah, almost, isn't it? That for every...
I actually like that.
Oh, wait, hang on, I'm getting confused. There's actually two graphs, isn't there? Yeah, so if we do the consumer one, the demand one goes down, doesn't it? Yeah, so let's do demand, it goes down. So yeah, as the quantity increases by 1, the price drops by 70 cents. So that means that, if I get my economics right, for every extra unit the customer buys, the price needs to be 70 cents less. No, you're looking at me like, is that right? Well, you did it. This is semester 1, isn't it?
But it must help if the price goes down, the quantity goes up.
If the price goes down. True. Maybe we'll do an example with supply demand. Let's do that one.
If you calculate the elasticity, the formula is the same because
The elasticity is the change in the
In
what?
quantity or
Oh, you use the same letters, delta.
Yeah.
Fantastic. So what do you use for elasticity? Now here is Q and here is P, and if we do demand, it goes down, and the slope is minus, going down, delta P over delta Q. Ah, you have it inverted. Ah, okay. So it's not the slope for you. It's something weird. Yeah, okay, fine. Oh, so then that means for you then that the slope will be 1 over the elasticity. You said it's upside down. Right? Yeah. So why do you do this in economics? Who knows? Okay, fine. So for economics, you don't use anything with the slope really. You use the other one, delta Q over delta P. Yeah. Oh, the elasticity of supply is the other way.
Yeah.
Ah, but why didn't you say so sooner? Right, so it goes up, and this is Q, and this is P, and elasticity of supply is delta P. Is there anything you do that is this way? Fine, forget about it. I was trying to relate it to economics. I can see this is pointless. Okay, so there's still a couple of minutes left. You can practice drawing some of these. In the exam, remember, you must pass through the average, and when you draw your line, try to get it going through the middle of the point. Now, of course, in the exam, his line and his line will be different, and that's fine. But you don't want it to be too different. And in the next lesson, we'll see a formula for calculating this line exactly. You know what I mean? Yeah. So for today, I want you to practice making scatter plots. So you can do that for a few minutes.